Welcome to Spring LIB.
Hi, let us look at this problem where you have a rod which is sitting at a wall which is not straight, not vertical, but it's inclined such that the top of the rod is at a distance 300 millimeter, and the the distance from the point C is 125 millimeter. The length of the rod is 500 millimeter, and let's say A starts moving left with velocity 1.4 meter per second. Then what is velocity of B and what is omega? So like in any this kind of problem, you break the motion into translation plus rotation. So let me draw the rod. So if this is our rod, then we know that the translation motion is being provided by VA, which is V naught. And then the rotational motion is coming if you fix this point A, because you know the velocity, the rod is falling. So omega is going to be in this direction, and VR is always perpendicular because it's omega cross R. So it's going to be perpendicular to this rod and follow this direction. Then the second step in any of these kind of problems is to break up the velocities, which are translation and rotational velocities, um, along, parallel, and perpendicular to motion. So in this case, the motion is going to be along the inclined wall. So we will break them along parallel and perpendicular to the wall. Okay, so this was our wall. So, and this is our rod. So, so angles here are slightly tricky, so we have to be careful. Let me use different colors so that we don't make mistakes. So, okay, so, right. So this is our rod. So let's denote rod by a different color. This is our rod. And let's denote our wall by a different color as well. This is our wall. Okay, now, so this is our velocity v naught, which is translational velocity, and then the rotational velocity is perpendicular to the rod, so it's going to be vr here. Now we need to break these into perpendicular and parallel to the rod, so we have to break them along the blue line and perpendicular to the blue line here. Okay, so we need angles. So what is this angle? So we know that this is part of a right angle triangle where we know the height of the right angle triangle is 300 millimeter and the base is 125 millimeter. So tan theta will be perpendicular by base equals 300 over 125. So we cancel them. I think 25 can divide both, so 12 over 5. But usually we need sine theta and cos theta. So to get them, we just imagine a similar triangle with perpendicular 12 and base 5. So what will be the hypotenuse? This will be 12 squared plus 5 squared square root, Pythagorean triplet. So this will be 13. So then cos theta will be base over hypotenuse, which will be 5 over 13. And sine theta will be perpendicular over hypotenuse. This will be 12 over 13. So we got these values. So if this angle is theta, then this angle is also going to be theta. So we can easily break V naught now because we know the angle of V naught. So V naught cos theta and V naught sin theta can be easily computed. Okay, but we also need to break VR, and for VR we need this angle. What is this angle? So for this angle we'll need this angle first. So okay, so this angle, let's call it phi. Then we know that the length of the rod is 500. So this is part of a right angle triangle. So sine phi we can write not theta, phi. This is perpendicular over hypotenuse. So perpendicular is 300 and hypotenuse is the length of the rod, which is 500 millimeters. Millimeters cancel, so it's 3 over 5. So if we again draw a quick triangle which perpendicular and hypotenuse 3 and 5, we know that the base is going to be 4 because it has to be Pythagorean triplet such that the sum of the hypotenuse squared is basically the sum of perpendicular squared and base squared. So you can check that this is correct, and then cosine of phi will be base over hypotenuse, which will be 4 over 5. So now we have got these values. Okay, so if this angle is phi, this angle is theta, then, and if this is 90 degrees, then first of all, this angle is going to be theta minus phi, because exterior angle of a triangle equals sum of interior angles. So this gave us, so that means that basically phi plus theta minus phi has to be equal to theta. So that's why this angle is theta minus phi. Now VR is at an angle 90 degrees to the red line. So if we extend VR so that we can carefully draw our angles, so this angle is going to be 90 degree minus theta minus phi. So this angle, the angle we are after, now this is perpendicular to the blue line, and we already know that the angle VR makes with the blue line is 90 degree minus theta minus phi. So this angle is going to be just theta minus phi. So now we know all our angles. So let's go back full screen. So now we can write down all the components. So the components, let's draw another clean vector diagram here at point B. So this is my, so again, let me just use the same color for the walls. So this is going to be blue. Okay, so my components now, if I look at my diagram here, so the component perpendicular to the wall is going to be V naught cos theta. The perpendicular along the wall, sorry, the component along the wall is V naught, along the wall is V naught cos theta, and perpendicular to the wall is actually V naught sin theta if you look at the angle, because it's making theta with the wall and 90 minus theta perpendicular to the wall. So it's cos theta, this is sin theta. Okay, what about VR? So in VR, we know that this is theta minus phi, so this will be VR cosine theta minus phi, and the component of VR along this will be VR sine theta minus phi. Okay, so now we have broken our components along and perpendicular to the walls. So now it's just a matter of writing down. So the third step is always add and solve for motion. So the motion is going to be along the blue line, so along this direction, because we know that the rod is going to slide along this direction. So these perpendicular components have to be equal. So V naught sine theta has to be VR cosine of theta minus phi. So what is cos of theta minus phi? It's VR cos theta cos phi plus sine theta sine phi. This is just trigonometric identity, and we put down the numbers. So V naught was, so let's keep this V naught as V naught. We'll put the final numbers at the end. Sine theta was 12 over 13. So this is, so VR is omega times L, because this is omega L sine of 90 degree because we already figured out the direction. So this is just omega L. This is our VR. So omega L times cosine of theta is, let's check, cosine of theta is 5 over 13. So it's 5 over 13. Then cosine of phi is 4 over 5. Then plus sine theta is going to be 12 over 13. And sine of phi is 3 over 5. Okay, so 5 cancels 5. And actually it's better not to cancel them because we are going to have them in the denominator anyways because we have to take the sum. So let's just keep them like this. So then finally v naught, so 13 can cancel all the 13s in the denominator, and then we are left with 12 times v naught equals omega L. Then my pen is slipping, so let me just, yeah, omega L, and then 5 cancels 5, and this number is 12 these are 36 over 5, so this is 7.2. So 7.2 plus 4 is 11.2. So omega is going to be 12 v naught over 11.2 L. So this is our omega. We can put the values of v naught and L and get the correct answer for omega. Now, what about VB? So VB is going to come, as we see in this part, from rotational translational components along the blue line. So this is going to be V naught cos theta plus VR sine of theta minus phi. So this is going to be V naught cos theta plus VR. This is again a trigonometric identity, sine theta cos phi plus cos theta sine phi. Actually, there will be a minus here because it's sine, not cosine. So minus. Okay. So this is V naught cos theta is 5 over 13 plus VR is omega times L, and then sine theta is 12 over 13, cos phi is 4 over 5 minus, let me just check if I'm writing them correctly. Yes. Yes. Okay. So cos theta is 5 over 13 and sine phi is 3 over 5. So this will be 5 v naught over 13 plus omega times L is just 12 v naught over 11.2, which is, and then multiplied by subtraction of 12 times 4 minus 5.3, 5 times 3. So 12 times 4 is 48, 5 times 3 is 15. So 48 minus 15 is 33 over 65. So 11.2, let's write it in terms of fraction as well. So the fraction of 11.2 was basically so we solved it here. So in terms of fraction, this was just 20 plus 36 over 5. So this was 56 over 5. That's how we got 11.2. So this number 11.2 will be 56 over 5. Does it help us cancel anything? Probably the 65. So let's just replace 11.2 by 56 over 5. So this 5 cancels this. We get 13. And anything else cancels. 2 6s are 12. 2 28s are 56, then 2 4 2 3s are 6, 2 14s are 28. So eventually we end up with 5 v naught. So we take v naught as common, and we have 5 over 13 plus 3 times 33 is 99, divided by 14 times 13. 14 3s are 42, and then 14 1 and plus 4, so 18. Okay, so this number, let's calculate. So I'll just use a calculator to quickly punch down the numbers. 5 over 13 plus 5 over 13 plus 99 over 182. So this number turns out to be 0.93. So it's 0.93 V naught. Okay, so now we have both our numbers. So V naught is 1.4, so 0.93 times 1.4 meter per second. So this will be 14 3s are 42, and then 14 9s are 126. 126 plus 4 is 130, and then decimals after 1 2 3 points, so it's 1.302 meter per second. That's our VB. And omega was 12 over 11.2 V naught over L. So this will be, L was 500 millimeters, V naught is 1.4 meters per second. 500 millimeters is basically half a meter, so it's 0.5 meters. Make sure that your units are always correct, otherwise you will make a mistake. So that's why we are using everything in units. So we cancel the meters, and then 0.5 times 11. So 0.5, we take one decimal off here, so one decimal moves here as well. So it's 14 times 12 divided by 11.2 times 5. So 14 times 12, 12 fours are 48. 12 1 is 12 plus 4 is 16. Then in the denominator, 5 times 11.2. So 11 times 5 is 55. And then 5 times 0.2 is 1. So 55 plus 1 is 6. This can be further simplified by dividing by, I think, 4. So 4 denominator gives us 14 by dividing by 4, and then numerator gives us 41. So it's 41 over 14 radians per second. So 41 over 14, we can divide this. So 14 twos are 28, then you will get 13. Take a decimal, then 2.9. Then you have 4 left over, so then again 2. So 2.92 radians per second. So this is going to be our omega. So we have figured out both these things. So remember, there are 3 steps. First, break the motion into translation plus rotation. Second is break the vectors or velocities perpendicular and parallel to motion. And third is add and solve. Basically, the perpendicular to motion components will be equal because they have to cancel to give 0, and parallel to motion component will actually give you the velocity you want. So follow these 3 steps, and these are just some mathematical and geometrical relations, and eventually you'll be able to solve any of these problems.